Let's work problem number 41 on page 172. I'll read the problem. It says, you take a running leap off a high diving platform. You were running at 2.8 meters per second and hit the water 2.6 seconds later. How high was the platform and how far from the edge of the platform did you hit the water? Neglect air resistance. This is a classic problem. There's a problem very similar to this on the test. So let's do this. So here's given. So we have a diving platform. Okay, and I don't know, it's on some kind of thing like this. And then down here is some water. And so this person takes a running start. So they're running. They have really long legs. All right, and so they're running at 2.8 meters per second. And what are we trying to find? Oh, and then, so they're going to go splash. Okay. And then there's, I usually like to draw a shark right here. So just. Okay, take a bite. Now, and we know the acceleration, and we know that they hit the water at t equals 2.6 seconds. That's when that happens. Notice that I draw a picture of the problem, and I show what's given around that problem to help me really thoroughly understand what's going on in that situation. And what are we trying to find? We want to know, see, the first thing I want to find is A. Well, it didn't give A, but it just says, how high was the platform? We'll just call it delta Y. Right, so we want to know delta Y. And then for part B, we want to know, it says, how far from the edge of the platform did you hit the water? Now I'm just going to assume that they mean the horizontal distance from the edge. From right here, we're going to call that delta X. So we want to find delta X. So let's solve. Well, notice something here. I want to use those kinematic equations. So I've got my equation list and I'm looking at it. You know, I'm saying, what do I know? What do I need to find? One thing you need to know is that this velocity is in the x direction, and that velocity in the x direction is a constant. But look at the picture. What is their initial velocity in the y direction? The initial velocity in the y direction is equal to 0. And I know what the acceleration is. What's the acceleration? Negative 9.8 meters per second squared. So I know the initial velocity, I know the acceleration, and I know the time, and I'm trying to find delta y. And there's an equation that has all four of those things. And that's the third one. And so now I just plug in my values. This is 0, so that whole term goes away. And then it's 1/2 negative 9.8 meters per second squared times squared. And so delta y, it's equal to a negative value, right? And you get negative 33 meters. Now, one of the things you can say is that, okay, our delta y was negative 33 meters, so how high is the platform? Therefore, the platform is 33 meters high. So in other words, since our diver dropped 33 meters, start at 33 meters off the ground, or up above the pool. Okay, let's do delta x. Now, what do I know? I know the initial velocity in the x direction, and what do I know about is true about the velocity in the x direction and projectile motion? Is there any acceleration in the x direction? No. So, therefore, the acceleration is 0. So the velocity is constant. And there's only one equation in projectile motion. So v naught x, that's 2.8 meters per second times 2.6 seconds. And so therefore delta x will be equal to 2.8 times 2.6, which I do believe is 7.3. meters. So, we've solved the problem. What's the big picture of this problem? Okay, is this. Notice, here's all my y stuff. I treat y completely separately from the x direction stuff. I notice, oh, my initial velocity in the y direction in this problem is 0. And I know what the acceleration in the y direction is. And I know time. Now, what's the only variable that applies in both the x and the y direction? Time. Time is the link between the x direction and the y direction stuff. So I want you now to, I don't know, stop watching this, if you're watching it. Go have a sandwich, take a break, and I want you to come back here, and I want you to do the problem over again without looking at the solution and make sure that you can do it independently and that you understand all the ins and outs of it. If you don't, you're a loser. Okay, any questions?
Okay, it's not really about how to do the problem, but like 33 meters, I don't know much about diving, so what if you dive?
You might be killed.
Okay, that's what I
But we did it for science.
You did it for science?
Yes.
So what's a negative 33 and a regular 33? A question like that, what would you want for an answer?
Okay, so the question was, should I put negative 33 or 33 meters high? Either one. If you told me delta y was negative 33 meters, I'm going to assume, I'm going to accept that as, okay, you know that the platform was 33 meters off the water. That is all.